In this section we are going to discuss about density of state. So for electron system or for some atomic system, we we are familiar with in atom there are some energy levels. Say this is energy level E1, this is energy level E2, and there are several energy levels like this. So there are discrete energy levels. So let us say this is conduction band and this is valence band. Say this is EV and this is EC, and say this is there is Fermi energy level that lies some in middle uh, for the intrinsic semiconductor, and it's gets shifted about for extrinsic semiconductor. For N type it's shifted nearby conduction band, and for p type it shifts near about valence band. So let us consider about some discrete energy levels available between these. So what is the density of these available? So how we can tell the nature of this energy levels? So there is a way we can define some function that's density, or say S, as a function of energy, which is equals energy state, or energy per unit energy number of, say this is G. So they say there are G number of states that is described by per unit. Say this gap is some energy per unit volume. So this is density of state. The energy density of a state is given by per unit energy per unit volume. So this is a function of energy. Why? Why this is function of energy? Because it depends upon energy gap. So between EV and E valence band and some given energy E, this is given by 1 upon 2 pi square 2m upon h bar. This is, I think, this is h bar to 3 pi 2. So the density of a state is given by this formula, and there is Fermi-Dirac probability function. So probability function, what is probability function? The probability for an electron to occupy that particular state that we have discussed in this section, in density of a state section. So this Fermi energy for an electron is given by Fermi energy probability function for an electron is given by 1 plus e to the power e minus ef upon kt. So number density Dn is equal to is given by Se, that is density of state into multiplied with probability. So why probability? So it will give you effective number of carriers that are going to stay there, stay at that location, and this is multiplied with energy dE. So for a small amount it is multiplied with dE, and we can integrate this to get the result. So let us discuss why we have multiplied with dE. So let us discuss about the nature of density of state. So density of state is function of energy. First of all, it is number, that is, say this is number of electrons or carriers, or say this is number of states similarly. So number of energy state, that is this one, the energy states. G per unit volume. So this becomes some number per unit volume into 1 upon energy and into probability. So this will give you effective number of states. Now for electron, let us multiply with energy. This energy and energy terms gets cancelled out, and that's why we get the number density, numbers per unit volume. That's why we integrate this term Se into Fe into De. So similarly for electron, this is probability. For holes, the total probability will be 1 minus the probability of electron. And on solving integration, we are going to take limit from EC to infinity for this EC to infinity for the function of electrons For electrons, because electron lie in conduction band and conduction band starts from some energy level EC and goes to higher, that is upwards. So that's why the limit is taken as EC to infinity, and this will given by EC to infinity 1 upon 2 pi square into 2m upon h square into 3 by power to the 3 by 2 EV minus EC into Fermi probability function 1 plus E minus EF into dE. And for whole it will be given by EV to in so this will for EV it will be like this. For EV limits will be minus infinity to EV, so that's why we can invert it. So on solving you will get the relation, some relation Ne for number density of electron, it will be Nc into e to the power minus Ef upon kT. Similarly for holes it will given by Nv into e to the power minus Ef minus Ev upon kT. So let us multiply these equation number 8 and equation number 9. So we will get Ne into Nh equal to Nc into V into this e to the power minus Ec minus Ev. Remember this term Ec minus Ev. Here Ef and Ef gets cancelled out, that these are opposite in sign, and the total it becomes Ef, and this is given as Eg. So this is N E N H into N C N V into E G upon K e to the power minus E G upon KT. So this will be given by Ne. In some books it is given by Ne into NH is equal to Ni square At cube minus E into E minus Eg upon Kt. So this is known as law of mass action. For intrinsic semiconductor, this Nc and Nv equals, and this is Ni square is equal to Ne into Nh. So there are the references which I have used to prepare this notes. So this is the book what I have preferred, and some PDF that I will attach in the description. To get his notes and the description for these references, follow the description. Thank you. So book you can prefer from yourself.